Hello everyone. Today I will be discussing our project which integrates four key technologies: web scraping, Flask, React Native and Expo Go. These are the building blocks that we have used to create our application, and I will walk you through each technology step by step from the basic to advanced concept. We will also dive into the code we have used and in the end demonstrate how these technologies work together in our final project. The first technology we are using is web scraping. In simple terms, web scraping is the process of extracting data from websites automatically. It's widely used to gather information like exam schedules, product prices, or any kind of public data available online. For our project, we used Python libraries such as Beautiful Soup and HTTPX to extract exam dates and details. We will show you some examples of how we implemented this in our project code. Next technology is Flask. We move to Flask. Flask is a lightweight Python web framework that allows us to build a backend for our application. In our project, Flask is used to handle HTTP requests, manages APIs, and serve the data scraped from the web. By using Flask, we can create a server that efficiently communicates with our front end built with React Native. I will also walk you through how we have set up Flask to process our data and serve it to the mobile app. The next technology used is React Native. It is a JavaScript framework used to build mobile application for both iOS and Android platforms using a single code base. This means we only write our app once and it works on both platforms. In our project, we have used React Native to create the user interface where users can explore and interact with the exam data we have gathered. I will show you the code examples of how we have designed the UI and added functionalities like buttons and lists. At last, we are using Expo Go. Finally, we come to Expo Go. It is a development tool that makes it easy to test and deploy our React Native application on actual devices without complex setup. It allows us to preview our app and test its functionalities in real time. This has made our development process smoother and faster as we can make changes and see them reflected instantly on our mobile devices. I will walk you through how we used Expo Go to develop and test our mobile app. Now that we have covered each technology, let's talk about how they come together in our project. We use web scraping to gather exam data, which is processed and stored by Flask on the backend. This data is then fetched by a React Native app where users can interact with it. Finally, using Expo Go, we ensure everything works seamlessly on mobile devices. I will now give you a demonstration of the project and show how these components work in unison. In conclusion, by combining web scraping, Flask for backend management, React Native for the mobile interface, and Expo Go for development, we have built a functional application that simplifies exam information access. Thank you. Now you can see the individual part of the tutorial such as web scraping and React Native so that you can easily understand what we are trying to achieve in our project.
Hello and welcome to this detailed tutorial. Today we are going to learn how to extract GATE exam dates from a website using Python. Don't worry if you are new to programming or web scraping. I will explain everything step by step. By the end of this video, you will have a solid understanding of how we extract data from a website and save it into a file for later use. Let's dive right into it. So first we have to understand what is web scraping. Web scraping is the process of extracting data from websites automatically using a script or a tool. So let us say we have a lot of data present in a website. We use some kind of a script to extract that data and then we can store it into structured data in database of files such as JSON, CSV or Excel files. So now as we have seen that what web scraping actually is, we have to understand that what problem we are trying to solve. So as you can see, we have been redirected to the site of GATE 2025 examination and here are the available dates, and we need to fetch these dates and store them somewhere so that we can further operate on such data. Now we are just going to inspect this page. Now here you can see the HTML structure of this particular page. uh, we are going to get redirected to the exact tag which contains the opening date of GATE online application processing system. So we got the tag over here. Now we are going to find the parent tag for which all the dates in this box are present. So we can see that call12 mb2 contains all the required dates that we need to fetch for further our work. Now we are just going to use this specific tag to search and extract the data, we can say crawl the data from this particular page using this particular URL, and we are going to write a Python script to do so. Now, as we have understood what our actual problem is, we are going to move to our next step, that is writing the Python script for extracting these data. Before we jump into the code, let's set up the environment by installing the necessary libraries. We will use two main Python libraries. The first one is HTTPX. This is used to make requests to website and download the content in the form of HTML. The second one is Beautiful Soup. This helps us parse and navigate through the downloaded HTML content to find the data we need. So here we have the command to install the required libraries. I have already installed them, so it is showing me that the requirements are already met. You can just copy this code and paste it on the terminal and then run it, execute it. Now, as we have installed the required libraries, the next step will be importing these required libraries into our program. So here we have the required libraries. We are going to copy this code and just paste it over here. Uh, these imports might look intimidating, but they are essential tools for our job. We have already discussed HTTPX and Beautiful Soup previously. Now we are going to discuss JSON and OS. JSON, we will use this to format and store the exam dates as a JSON file, and OS, this library will help us interact with the file system, like checking if a file exists or not. So for defining the function, we are going to move on to the VS Code, and as you can see here in below section 4, we can see the defined function. We are just going to paste it in our code, and we have got the required function with us. After defining the function, our next step will be making a request to the website. To get the data from the website, we need to send an HTTP request. We do this using the httpx.client inside the with block. So in the code, we can see the required snippet for it. The with block ensures that the client closes automatically after the request is done. Inside this block, we need send a get request to the URL which fetches the content of the web page. The response from the website is saved in the response variable which is present over here. You will notice the verify is equals to false, as you can see in the code. This is used to bypass SSL certification verification, which can sometimes cause errors when fetching from HTTPS websites during testing. You can remove this in production. So let us just copy this code and we are going to move to the next step. The next step is parsing the HTML content with Beautiful Soup. The response we get from the website is in raw HTML, which is hard for us to read or understand. So we use Beautiful Soup to parse the HTML content. Beautiful Soup turns the raw HTML into a more structured format that we can easily work with. In the code, as you can see, we have passed the HTML content of the particular site into a variable named soup, and we are going to use it here. Next step is finding the relevant section of the HTML page. Web pages are organized using HTML elements like div, table and tr. Our job is to find the element that contains the exam dates. We start by looking for a div with the class called 12mb2. As in the previous part of the video, we have already seen on the website what's the needed tag and the class we required for extracting the required dates. We have copied this part of the code which is containing the required tags and pasted over here. Now this class is specific to the section where the table of exam dates is located. Once we find the div, we search within it for a table that contains the actual date. This table has a class table detail, which is how we know it contains the information we need. Now that we have the table, we need to extract the exam dates. A table in HTML is organized in rows, that is tr, and columns, that is td. The tbody tag contains the actual table data, so we get all the rows inside it. Let us move on to the code that is required. Here we have put the required code, and the explanation for this is that for each row we extract the first and third column, one for the exam activity like registration start and the other for the corresponding date. The strip method is used to remove any unnecessary white spaces around the text. We store each activity date pair inside the activities dates list, and by the end of the loop this list will contain all the exam activities and their respective dates. Once we have extracted all the data, we format it into a string. Each activity and its dates are separated by a period, making the data easier to read. Next, we prepare a Python dictionary to store the GATE exam data. Dictionaries in Python allows us to organize data in key value pairs. Here the key is GATE and the value is another dictionary containing the exam dates. We have the code snippet for formatting the data in a particular format so that we can store it inside the JSON file. We are going to use this format. The next step is saving data to a JSON file. Now we need to save this data so that it can be accessed later. We use the JSON library to work with JSON files. JSON stands for JavaScript Object Notation, and it's a lightweight format used to data exchange. First, we check if the exam.json file already exists. Moving on to the code, here we are checking that if the exam data.json already exists. If it does, we load its content into a dictionary. If it doesn't, we create an empty dictionary. Then we update the gate exam dates in the dictionary. Finally, we write the updated data back into the exam data.json file, making sure to format it neatly with an indent of 2 spaces. After executing all the above steps, at the end our function extract exam date should look somewhat like this. And now we are going to try to call this function in our code and see what the expected output is. At the end of the script, we call our extract exam dates function and pass the URL of the important date page as an argument. When you run this code, it will scrape the dates, format them and save them into the JSON file. Let us try to run this code. Python gate.py, and as an output we get a file, JSON file, exam data.json. Here you can see under the section of gate we are finding the important exam dates, or we can say the data that we just wanted to crawl. We have got all the dates that we have previously seen in the video, and that's it. You have successfully created a Python script that scrapes gate exam dates from a website and saves them in a JSON file. I hope this tutorial was helpful and easy to follow. You through a detailed tutorial on Flask, a microweb framework written in Python. We will start from the basics and go all the way to some advanced feature, including how to set up a basic API in Flask. Let's begin by understanding what Flask is. Flask is lightweight and allows developers to build web application quickly and easily. It's very flexible, which makes it a great choice for both beginners and experienced developer. First, we have to understand what is Flask. Flask is often described as a framework because it provides the core essentials of web development without enforcing dependencies or giving unnecessary functionalities. Unlike larger frameworks like Django, Flask gives developers more control over the component they want to include in their application. It is written in Python and is commonly used for developing web APIs, single page applications, or even full stack apps where you need flexibility. We need to discuss what is the difference between Flask and other frameworks. Compared to other web frameworks like Django, Flask is considered minimalist. In Django, you get a lot of built-in functionality like an admin interface and ORM, that is Object Relational Mapper, for database interaction. Flask, on the other hand, gives you the flexibility to add only the features you need for your project. This is why Flask is popular for projects where speed and simplicity are important. It's easy to learn and doesn't have a steep learning curve. Our next step is setting up Flask, or we can say installing Flask. Let's talk about setting up Flask. It's really easy to get started. First, you need to have Python installed on your machine. Then you can use pip to install Flask. Once installed, you can create a simple app.py file. Here we have a very basic Flask app. We create a Flask instant using Flask name, as you can see on the screen. The name variable helps Flask determine the route path of your application. We define a route for the home page using the app.route decorator. This route maps the URL to a Python function called hello. When someone visits the home page, it will display hello world. Finally, the app.run function runs the Flask web server locally. The next step is routing in Flask. Routing is one of the fundamental concepts in web development. A route is a URL pattern that determines which function should handle a particular web request. In Flask, you define routes using the app.route decorator, as you can see in the example here. We define a route for the home page and another route for the about page. Flask will call the respective functions when someone visits these URLs. You can also pass variables in the URL as shown in the example, where username is passed in the URL, making it dynamic. The user's name is displayed in the greeting. The next step is rendering HTML templates. Most web applications require rendering dynamic HTML content. Flask supports templates using Jinja 2, a templating engine that allows you to insert Python logic and variables inside HTML. Here's how it works. We use the render template function to render HTML templates stored in the templates folder. Inside the HTML file, we can inject dynamic content using Jinja 2 syntax, which allows us to write code inside curly braces. For example, we can pass a variable from the Flask route into the HTML template. The next step is handling forms in Flask. Flask also makes it easy to handle forms. In this example, we use the request object to get form data from the user input. When the form is submitted via post request, Flask processes the data and returns a response. Forms are essential in almost every web application for things like user registration, login, and more. Flask also supports Flask WTF, an extension to manage forms more effectively, including validations. The next step is working with JSON in Flask. Flask can return JSON responses, which is useful when building APIs. In this code, you can see JSONify converts the dictionary user into a JSON response. The next step is Flask and databases. Flask doesn't come with built-in database support, but you can integrate it with databases like SQLite, MySQL, or PostgreSQL using extension like SQL Alchemy. In this code example, we connect to an SQLite database using SQL Alchemy. We define a simple model for a user which represents a table in the database. Flask allows us to easily query the database, insert records, and retrieve data to render in templates. The next step is error handling in Flask. Flask allows custom error handling. As you can see in the code, we can custom build a error page that this page doesn't exist. Now let's talk about building a REST API in Flask. Flask makes it very simple to build API using the JSONify function to return data in JSON format, which is standard for APIs. In the example on the right, we have an endpoint exam data that serves JSON data from a file. When this route is accessed via a GET request, it reads the exam data.json file and returns the data to the client as a JSON response. Now let's talk about building a REST API in Flask. Flask makes it very simple to build APIs using the JSONify function to return data in JSON format, which is standard for APIs. In the example on the page, we have an endpoint exam data that serves JSON data from a file. When this route is accessed via a GET request, it reads the exam data.json file and returns to the data to the client as a JSON response. Now, as we dive deeper into this code, first we import necessary libraries including Flask, JSONify, and CORS. CORS is used to allow cross-origin requests, which means our API can be accessed from other domains. Next, we create a Flask application instance and enable CORS for the entire app. The main logic resides in the route slash exam data. This route listens for
get request and loads a JSON file containing exam data. It uses the JSON module to read the file and return the data as a JSON response. Finally, the Flask application runs on the 0.0.0.0, meaning it will be accessible from any machine on the network. The advanced feature deployment: when your Flask app is ready, you will want to deploy it for the public to access. Flask apps can be deployed using services like Heroku, AWS or Google Cloud. In production, you won't be using Flask built-in server for deployment because it's not suitable for handling production traffic. Instead, you will use a production server like Unicorn or UWSGI, like with a web server like Nginx. In conclusion, Flask is a powerful yet simple framework that allows you to build web applications and APIs with minimum setup. Today we covered the basics including routing, rendering, templates, handling forms, working with databases and creating a REST API. Flask flexibility and ease of use make it an excellent choice for both beginners and experienced developers. Here, for the explanation of this code, let us try to understand this code line by line. Flask, the main class from the Flask framework used to create the web application. JSONify, a function from Flask that converts Python dictionaries to JSON and sends them as HTTP response. CORS, as we have already discussed, is an extension for handling cross-origin resources sharing. In Flask, CORS allows a server to indicate any other origin domains from which a browser can load resources. JSON, the built-in Python module used to work with JSON data. In this case, it reads the JSON file containing the exam data. Next is creating a Flask application instance. Here you can see app is equals to Flask name. In this case, initializes the Flask application. The name argument tells the Flask app where to look for resources like templates and static files. Next is enabling the cross-origin resources sharing. Here we have enabled CORS. The next step is creating an API endpoint. Throughout this code, we are just going to understand it in brief that app.route slash exam data method is equals to get. This line defines a new route URL endpoint at exam data. The methods is equals to get part specifies that this route will respond to get request. The function getExamData defines the function that will handle the request to this route. With open scraping examdata.json opens the examdata.json file located in the scraping directory one level above the current directory for reading. The with statement ensures that the file is properly closed after reading. Data is equals to json.load file, as you can see on the 11th line, loads the content of the JSON file into the data variable as a Python dictionary or list depending on the structure of the file. At the end, return JSONify data converts the data dictionary to JSON response, which will be returned to the client. At the end is the running of the Flask app. This ensures that the Flask app runs only if the script is executed directly and not imported as a module elsewhere. The debug is equals to true enables when the app is in debug mode. It will automatically reload if the code changes, and it provides detailed error messages in the browser if any error occur. This host allows the Flask app to be accessible on all public IPs of the machine as discussed earlier, not just local host. This is useful if you want the app to be available externally, example on a local network or cloud server. The code flow, as we can see, is the Flask server start running and listens to the request on all interfaces. When a get request is made to exam data, the server opens examdata.json file, loads the exam data into a Python dictionary, converts it into a JSON response using JSONify, and sends it back to the client. This code is suitable for creating a simple API that retrieves and serves exam data stored in a JSON file while also handling cross-origin requests. Hello everyone, I am excited to talk to you about React Native, one of the most popular framework for building mobile applications, and explain how it helps us create cross-platform apps. First of all, we should discuss what is React Native. Let's start with the basics. React Native is an open source framework created by Facebook
It allows developers to build mobile application for both iOS and Android using a single code base written in JavaScript or TypeScript. The major benefit here is that you can write one set of code and it will work on multiple platforms, saving time and effort. React Native bridges the gap between JavaScript and native code, providing a seamless experience and enabling us to build high performance mobile apps with a native look and feel. Now, why should we use React Native? First of all, the cross platform development. As I mentioned, it all allows you to develop apps for iOS and Android using a single code base. Second is reusable components. You can build components that can be reused across your app. The third point is fast refresh. It allows developer to instantly see the result of changes they make in code during development. Fourth is access to native modules. You can also integrate native codes Java, Swift, Objective-C into your React Native app when you need platform specific functionalities. The fifth point is large community. It has a vast community of developers and a large ecosystem of libraries, making it easier to find solution to common problems. The next topic is how do we use React Native to create mobile apps? To get started, you need to install Node.js and npm, which is the package manager of JavaScript. Use the React Native CLI to create a new project by running a command like npx react native init my project. You can then start developing by writing your components and styling them using JavaScript and React components. React Native applications are made up of components that describe what the UI should look like. Each component is like a self-contained module that can have its own behavior and styles. We are going to see a demo, or I should say explanation of code after this, that we have used in our project for displaying the details of different examinations that an engineer could pursue after graduation. Now let's dive into an example code to show how we build a mobile app using React Native. I will explain each part of the code step by step and share what we have learned. So first, let's look at this part of the code as highlighted by the cursor. Here we are importing React along with some key hooks such as useState and useEffect. The useState hook is used to manage the state within our functional component, while useEffect allows us to fetch data when the component loads. We are also importing various components like React Native, like view, text, scroll view, and more, which help in building the UI for our app. The next part is again being highlighted by the cursor, and here we define a functional component exam details. It receives routes as a prop, which gives us access to the exam name that is passed when navigating to this screen. The state variable details holds the information about the exam, which is fetched from a server. Expanded keeps track of which section like syllabus or exam date is expanded in the UI. Then the next snippet of the code is the use effect. In the use effect hook, we are fetching exam data from a server. When the data is successfully retrieved, we store it in the detailed state using set details. If the exam is not found, we handle it by logging an error. This is a conditional rendering block. If the details are not available, it displays an error message saying exam not found. This helps in gracefully handling errors in the UI. Then the toggle expand function helps us to handle the expanding and collapsing of different sections. We are using layout animation to animate the transition, making the UI feel smooth and responsive. At the end of this tutorial, we are also going to show how our project is working in. Now, the next portion of the code is simply the render section. The render section function takes the title, content, and section key as argument. It renders each section dynamically and provides the toggle functionality when the user taps on it. The return over here, which is present, uh, finally we return the JSX layout for the component, which includes the navigation bar, the exam title sections with exam details, and a button to visit the official website. So throughout this, what have we learned? it is a complex code. Here we have also designed what the page should look like. It is somewhat similar to CSS and JavaScript, but it is a complete different method for developing apps. Now, what we have learned throughout this code, we have learned how to use React hook like use state and use effect to manage state and perform side effects. The second is work with functional rendering to handle missing data, create a smooth UI experience with layout animations, dynamically render sections and expand collapse them based on user interaction. Use React Native components like scroll view, touchable opacity, and text to build a mobile friendly interface. That we have included in the code, as you can see on the screen, that the required functions we have imported them inside the code. In conclusion, React Native allows us to create efficient cross platform mobile apps with a single code base. The example we explore today is a small part of the larger app, but it demonstrates how React Native simplifies mobile app development while still giving us access to native features. Now, let us look at the code, React Native code for the home screen of our mobile app. This React Native code defines a home screen component for a mobile application that displays a list of exams and allows the user to view details about each exam. The code utilizes use state, use effect, use ref, and animated components to create animations and manage state for the screen. Let's break it down step by step. First of all, the imports React, use state, use effect, use ref, essential hooks from React for managing component state, side effects, and references to animated values, view, text, style sheet, touchable opacity, dimensions, flat list, animated images. Components are utilities from React Native for rendering the UI and styling and creating animations. Dimension retrieves the device's screen dimension, width, and height, which are used for responsive design. Now, first let us look at the const exam, that is containing the list of all the exams, an array of objects representing different exams, each with an ID and name. These exams will be displayed in the UI. The next thing in the code is the const home screen containing the show main, fade logo, and fade main. Show main, a state variable to control whether the main content exam list is displayed or not. Fade logo and fade main, animation references using useref and animated dot value to control the opacity of the logo and the main content. Now, the use effect hook, that as you can see in the code, use effect defines an animation sequence when the component mounts. The logo fades in, fade logo anim, opacity goes to 1. After a delay of 2 seconds, the logo fades out. The main content fades in. After the animation ends, set show main true is called to display the main content. Now, the next step in our code is the rendering the exam list, that is this portion of the code. So, render item defines how each exam in the exam array is displayed. It creates a box, exam box, with the exam's name and a button that navigates to the exam details when clicked. Navigation.navigate navigates to another screen, exam details, and passes the selected exam's name as a parameter. Now, previously we have looked how we are exporting our data or the JSON file containing the data through the Flask code and exporting it into a local server. Now what we are doing is this portion of the code is only extracting that data from the server and presenting it on the exam details portion. What I'm trying to say is that when we click on the name of the exam, it fetches the exact section, or we can say the exact exams data from the database and present it on the exam details page. Now we move on to our main return block, that is present over here. So it consists of logo animations. The animated dot view holding the logo fades in and out based on fade logo anim. Main content, when the show main is true, as you can see main content over here, when the show main is true, the exam list, flat list, and a description appear with the fade in animation controlled by fade main anim. Flat list renders the exam list in two columns. Now what we are using for styles is
The style sheet object defines the styles used in the component. The first one is container, sets up a view with a black background. Logo container holds the animated logo during the fade in fade out sequence. Main content contains the list of exams and description once the logo animation finishes. Exam box, exam name, button text, styles for the exam list items, and the button to view details. Now, what we have seen in this, so through this code we can say that React Native is a framework for building mobile apps using JavaScript and React. It allows developers to create apps for both iOS and Android platform with a single code base. Structure of the app begins by displaying a logo that fades in, stays for a couple of seconds, and then fades out to reveal the main content, a list of exams. Animations in React Native are handled using the animated API. We define fade logo anim and fade main anim to control the opacity of the logo and main content. Useref is used to create animated values, and useEffect manages the timing and sequence of the animation. Now, displaying the exam data. The exam list is stored as an array of objects. Each exam has an ID and name. In the code base, you can see that each exam is consists of ID as well as the name of the examination. We use flat list to render the list in two columns. Each exam item is wrapped in a touchable opacity component that navigates to a details screen. And the navigation part, we use React navigation to handle navigating between screens. When a user taps the open button, then they are taken to the exam details screen with the exam's name passed as a parameter. The style sheet, we set up a dark background style and exam boxes and buttons and make the app responsive using screen dimension. In conclusion, with React Native, we can build interactive and responsive mobile apps with animation as well as navigations. Welcome everyone to another part of this tutorial. Now we are going to take a basic idea about Expo Go. Using the Go app is a crucial step in developing and testing React Native application. Here's a detailed breakdown of how to use Expo Go, what you have learned for your project, and a script that summarizes this knowledge. So first of all, we have to understand what is the basics of using Expo Go. For that, we have to dig deep inside what is Expo Go. Expo Go is a mobile app that allows you to run and test React Native applications on your device without the need for native builds. It supports live reloading, which means any changes made in the code are instantly reflected in the app. The next step is the setting up of the environment. First of all, we have to install Node.js, and we have to ensure that Node.js is installed in your machine as Expo Go requires it for the development environment. The second step is to install Expo CLI. You can run the command npm install-g expo cli in your terminal to install the Expo command line interface. Now, create a new project. Use Expo init project name to create a new project. You can choose a template like a blank or tabs template. Now, starting of the project. Navigate into your project folder using the cd command. Start the development server with Expo start. This will open a new tab in your web browser with a QR code. Using the Expo Go app, install the Expo Go, download the Expo Go app from the App Store or Google Play Store. Scan the QR code, open the Expo Go app and scan the QR code displayed in your browser. This will load your project in Expo Go app on your device. Third, live reloading. Any changes you make in your code will automatically update in the Expo Go app, allowing for fast iteration and testing. The next step is accessing device features. Expo provides APIs for accessing various devices, features, camera, location, etc. without having to write native code. You can import these APIs in your React Native components as needed. Now we are going to discuss few advanced features of Expo Go, such as publishing your app. Once your app is ready, you can publish it using Expo Publish, making it accessible for anyone with the link. The second is building standalone apps. You can create standalone app using Expo Build Android or Expo Build iOS, which generates APKs or IPAs for distribution on app stores. The third feature is using Expo SDK. The Expo SDK includes numerous components and APIs that enhances the development experience such as animation, navigation and more. Now, what we have learned through Expo Go in our project is first the project structure. Understand how to structure your React Native app using component and state managements. The second thing is animation and UI UX designs. How to implement animation like fading effect to enhance the user experience. Navigation, utilize React navigation for transitioning between screens in your app. Third is data management, how to use flat list to render list of data dynamically and efficiently. And the last one is the styling, applying styles using style sheets to create an appealing layout. And in conclusion, Expo Go simplifies React Native development.
Welcome guys to another part of this tutorial. In this portion we are going to discuss the basics of Python so that one can start their journey for this project. First of all, we have to understand what is Python. So Python is a popular high level programming language used in various applications. Python is an easy language to learn because of its simple syntax. Python can be used for simple tasks such as plotting or for more complex tasks like machine learning. Variables, objects and classes, these are a very crucial part of any programming language. A variable is a reference to a value stored in a computer's memory. Variables can be sorted into a variety of categories such as numbers, boolean values and sequences. An object is a collection of data from a computer's memory that can be manipulated. Few of the important points are: all the variables are objects, although some objects can be defined by data referred to by multiple variables. Another point is methods are the functions used to act on an object's data. They describe what your object can do. The next thing are classes. A class is a collection of objects who share the same set of variables or methods. The definition of the class provides a blueprint for all the objects within it. We can call that instances. Instances may share the same variable, but they do not share the same values for each variable. So in the diagram or depiction on the right side of the page, you can see that there is a class called car. Now it has different, or we can say variety of objects, that is polo, mini, beetle. So let us say that the first object is instance 1 containing color pink and name polo. Then there is instance 2 which has the color red and name mini. Then there is instance 3 whose color is blue and name is beetle. So each object has its own unique existence. Now we are going to understand basic syntax rules in Python. So the name of your variable is placed on the left of the equals to operator. What we understood by this is that the variable you are trying to declare in Python language will have its name on the left side and the value which is getting assigned to it on the right side. Most variable names are in camel case, where the first word begins with a lowercase letter and any subsequent word are capitalized. Variable name may also appear in snake case, where all words are lowercase with underscores between words. The assignment operator equals to sets the variable name equal to the memory location where your value is found. The value of your variable hello world is placed on the right of the operator. The type of this value does not need to be stated, but its format must abide by a given object type as shown in the given diagram. So what we understand is that if you want to declare a variable named a and want to assign it an integer value of 7, you can simply write a is equals to 7. And if you want to assign, let's say, name to a variable as b and you want to make it as an string, so you can directly write b is equals to hello world. So the Python language also consists of functions. Now we have to understand what is the syntax of a function. We write def, which indicates that you are defining a new function. Then the name of the function refers as by convention this name is typically lowercase and represents a verb or action. Now a and b refers to parameters that can be used within the state of your function's definition. If your function has no parameter, then empty parenthetical is used. So you can see the structure or the basic syntax at the bottom of the page. We are defining a function that is named function, and we are passing two of the parameters into it, that is a and b, and we are returning a value a plus b. So the return statement is an optional statement that will return a value for your function to your original call. Now, how are we going to call a function? Call the function by referring to its name and by placing any necessary argument within the parenthesis separated by commas. Let us say you want to also assign the value which is getting returned to a variable. So if you wish, you can set your function call equal to a variable. The value returned by the function will be assigned to your variable name. In again at the bottom of the page you can see a simple example of how a function call can be made. Now the common data types and operators. First we have to understand what a data type is. A data type is a means of classifying a value and determining what operations can be performed on it. All objects have a data type. Now operators are symbols used to carry out specific functions or computation. As you have seen previously that there is an assignment operator, that is equals to, which is used to assign values to the variables. So at the bottom left of the page you can see a table which consists of operators as well as their description. They are arranged in their preferences from top to bottom, and the preference is decreasing. So at the top we have exponentiations, then we have complements, then we have addition and subtraction, then we have right and left bitwise shift, then we have bitwise and, then we have bitwise exclusive or and regular or, then we have comparison operators, then we have equality operators, then we have assignment operators, and so on. Now we are going to discuss what are the data types in Python. So we can say that the classes are bool for, and the description for it is a boolean value. Similarly we have int, that is an integer, then we have float, that is a floating point number, then we have list, that is a mutable sequence of object, tuple is immutable sequence of objects, str is character string, set is unordered set of distinct object, frozen set is immutable form of set class, dict associative mapping, or it is also known as dictionary. Next we have input output. So input functions allow user of a program to place values into programming code. Now the point here is the parameter for an input function is called a prompt. This is a string such as enter a number. So the user's response to the prompt will be returned to the input statement called as a string. To use this value as any other data type, it must be converted with another function. Now the print function allow program to output a string to users on a given interface. The point here is the parameter of this function is of any type. All types will be automatically converted into strings. Now every language has its own syntax for if else statement, but over the line it is the same for all. So if else statement allow programmers to adapt the function of their code based on a given condition. Let's say if a given condition x is divisible by 2 is true, then the statement following the if will be executed. If the condition is false, the statement following the else statement will be executed. The condition is tested using boolean operator is equal to or is not equal to, and used to test multiple condition, and or used to test if at least one condition is true. Additionally, else if statement elif can be used to provide unique coding statement for multiple condition. So with the use of if and elif we can form an if elif ladder that you can see at the right side of the page. So it will start checking that whether the condition is true for if statement or not, then it will check if it is true for elif or not.
and it will keep going downward till one of the condition gets true and executed. Now the next topic is for loops. For loop perform the same task for the number of times specified by an iterable, something that can be evaluated repeatedly such as a list, string or range. For defines the for loop. X is the variable defining the number of times the statement within the loop are executed. So again at the right side of the page you can see that for x in range 0, 5, 1 print my int. So we can see on the left side what is the description for this particular code. The range start stop step function is often used to define x. The starting value is defined by start, the final value is defined by stop minus 1, and the magnitude at which x changes between loop is defined by step. In is a boolean operator that returns true if the given value x is found within a given list, string, range, etc. At last we have while loop. While loops are statements that iterate so long as a given boolean condition is true. Again at the right side of the page you can check that there is a variable x which has assigned value 0. Now we have put a condition that while x is smaller than 5 print another variable my int, and on each step, or we can say on each iteration, keep increasing the value of x by 1. So x, the variable determining whether or not the condition is met, is defined and manipulated outside of the header of the while loop. The condition x is smaller than 5 is a statement containing a boolean variable. Break is a statement used to exit the current for or while loop. Continue is a statement used to reject all the statement in the current for or while loop iteration and return to the beginning of the loop. So now I have given you a basic understanding of Python programming and its syntaxes. You can try it.
Now moving on to the project demonstration, we are going to display how our project is working. On the terminal, we are first going to move to the Flask server folder where our Flask API.py file is present. This file, as I have explained previously, is going to deploy the data on the local server on which we are connected. So cd Flask server, then we are going to execute this program. So python flask API.py. So our data is successfully deployed on the local server. Next, we are going to open a new terminal in which we are going to run our application through npx expo start. Once the application has started, we have to open the Expo Go app on our mobile, and then we can just scan this QR code on it, and our application will start working accordingly. At our mobile, in the Expo Go application, here we are going to scan the QR code that we have previously seen on the terminal and try to run our application in mobile. So scan QR code. Now it is fetching all the data from our machine. As you can see, our app is working. So this is our home page, which is consisting of all the exams list. Then if we open on any individual exam, let's say GATE, so here we have different information about GATE examination such as description, exam dates, syllabus, exam format, important topics, and this is all is getting fetched through the scraping codes that we have on our machine. On clicking on this visit official website button, we can get redirected to the official website.
and here is the list of the previous year question papers. On clicking on them we can directly download them. Now I'm going to show you a few more example. Let's say we open the PMP. Here we have description, then exam dates, syllabus, exam format, important topics, and again we have visit official website. So this is the working project. Thank you.